try to talk about what we have taken up in carbohydrate metabolism. You started with structure of carbohydrates, di ba? Structure and function. So what do we have to remember there? One of the important things to remember is the linkage between two monosaccharides or more. We have your glycosidic linkage. And the glycosidic linkage could either be 1,4, 1,6, 1,1, or 1,2. And you know what that means. Okay? And then there is alpha 1,4 linkage. So what do you mean by that? And what is meant by beta 1,4 linkage? Usually when we have your beta 1,4 linkage, that particular disaccharide for us Asians in general will not, our gastrointestinal tract cannot tolerate it because we do not have the necessary enzyme to break that beta 1,4 linkage. And I am referring to your disaccharide lactose. And that is the problem in lactose intolerance. Because as we grow older, we lose our lactase. We do not produce lactase. So the production of lactase in our intestine is having its own time limit for us Asians in general. So we have lactase deficiency. Okay? Now, aside from that, what do we have to remember? Okay, the ability of our, we have taken up glycogen formation in our liver and in our muscles, and the glycogen structure is dependent on alpha 1,4 linkage, which produces a straight chain of glucose. And then at the branches, we have 1,6 linkage, alpha 1,6 linkage. Okay? So what else to remember there in structures? Okay? From there, the digestion of our starch, which is our principal carbohydrate. And we start with digestion in the mouth. We have the enzyme amylase, salivary amylase, which breaks our chain of glucose present in starch. And the end product by amylase activity on starch is maltose. Of course, there are some few free glucose that has been released, but it is mostly maltose that is formed. That is, of course, if you are chewing your food properly. And we are always very, very busy. And sometimes eating is not our priority. If we should eat, we just gobble our food. And there is almost no digestion going on in your mouth. Okay, so you swallow the food, it goes into the stomach. In the stomach, you do not have enzyme for digestion of starch. The amylase that goes with the bolus of food that has been swallowed into the stomach is made inactive by the high acidity in the stomach, courtesy of your hydrochloric acid. And so there is no digestion, even though you swallowed your amylase together with the food. But because the environment is not hospitable for the activity of your amylase, the amylase does not work. Okay? All right. It stays in the stomach for a while, or maybe 1.5 to 2 hours, and then it is emptied into your small intestine. The first part is your duodenum. Okay? Your duodenum, yeah, the pH changes. The pH changes and it becomes a high pH and becomes alkaline. It is no longer acidic. All right, this has an important, implication. The common ulcers in the intestine is found in the upper part of the duodenum. We call it duodenal ulcer. Now it is because when you swallow your bolus of food, when the bolus of food from the stomach goes into the small intestine, it is, of course, together with the hydrochloric acid. So which means that the first portion of your duodenum receives the acidic food. And so, if there is not much protection in your mucosa of the first part of the duodenum, they become vulnerable to the activity of the acid from the stomach. However, there is a remedy to that. There is your secretion from your pancreas. The secretion from your pancreas through the pancreatic duct and joins the common, hepatic, your bile duct, and you call it the common bile duct, and then it empties into the first part of the duodenum. And this pancreatic fluid contains so much of bicarbonates. And this more or less is going to neutralize the acid. Okay? All right. So what happens now? The food, acidic food from the stomach now is being neutralized by the bicarbonates secreted from the pancreas and into, and also it contains enzymes, pancreatic enzymes. And since we are talking about carbohydrates or starch, we will refer the enzyme for that starch from the pancreas, and that is your pancreatic amylase, similar to your salivary amylase. Okay? But they have a different condition. Your salivary amylase from your saliva and your pancreatic amylase coming from your pancreas. And so this pancreatic amylase further acts on undigested starch and it produces again maltose. Okay? As this food goes down to lower small intestine, okay, there you have secretions from the intestinal mucosa itself. And we have there enzymes, maltase, which acts on maltose, sucrase, which acts on sucrose, lactase, which acts on lactose. Now, as I've said, this lactase is very, very crucial for us Asians. As I said, generally we are lactose deficient when we become adults. While we are still young, especially when we are infants, we have lactase. But there is a time frame for the production of lactase for us Asians. So you will ask, how could your creator be have committed a mistake? Why is it that other people can tolerate lactose? Why is their lactase secretion still is going on even if they become old already? They do not suffer from lactose intolerance. Well, in the beginning, when there were just a few people on earth, now there are only two classes of people: farmers and shepherds. Farmers and shepherds. Farmers ask Asians, especially here in the Far East, the sun is the all year round, so we do not have winter. So which means that we can grow anytime our food, anytime we like. And that makes us lazy. Di ba? Because you can always say, the sun will come out tomorrow. I will just be planting tomorrow na. When tomorrow comes, he said, another tomorrow. No? But in other countries where there is winter, they have to time their planting. Otherwise, they could not harvest because winter is already there. So they have to time it. And that makes them, of course, masipag sila. Because they are guided by their calendar. While us, we can always look up and say, if the sun is there, bukas na, tomorrow na. Tomorrow na tayo magtanim. Di ba? All right. Those people there who have winter, during winter time, they do not have food because nothing grows. So, what is their food? Coming from animals. And mostly milk. And milk contains lactose. Diba? So in order for them to survive, their genes does not filter out when they become adults. They still produce the enzyme lactase. While us, we do not depend on milk. Diba? When we are weaned from milk, then our lactase production stops. No? Our lactase production stops. So that's why when we are become older, we cannot tolerate lactose anymore because we do not have the proper enzyme to break it. And why does it become, why do we have diarrhea and bloating? No? Now, when lactose is an osmotic compound, so while it is there, not acted by an enzyme to break it into glucose and galactose, it draws water from the intestinal walls. And so the stool becomes watery. Now, and lactose in the large intestine is acted upon by the bacteria present there. You know, your large intestine is inhabited by two kinds of bacteria, the friendly bacteria and the not so friendly bacteria. And so this not friendly bacteria acts on lactose and produces gas. No? Gas is formed. Methane gas is formed. You know, methane gas is explosive, di ba? Just like my background there is exploding. No? It can easily get. Your LPG is methane gas. Di ba? You use for cooking. So, well, if you can devise a way where you can make use of your methane gas, you can just put a tube to your anus and then directly to your gas tube. Joking only. Okay. No? So there you are. So there's bloating, and there is cramping, and there is diarrhea as a result of your lactase deficiency. Okay? Now, so you know already that you cannot tolerate lactose, so then you avoid the food that contains lactose. And the most common is, of course, milk. So you avoid milk products or dairy products. Call it. Okay, so that's how you survive. Or what you can do, you can take you can buy this from what you call you can buy this from, yes, you can have it from your ordinary pharmaceuticals, no? Pancreatin. Pancreatin contains lactase and all other enzymes to help digest the food, especially elderly people who have already problems with their enzyme production. So you can take pancreatin. Pancreatin contains enzymes for protein digestion, enzymes for fat digestion, and enzymes for carbohydrate digestion, especially lactose. Okay? All right. Now, how about the glucose or the monosaccharides now? As a result of the digestion, you have glucose, fructose, mannose, galactose that are now in your intestine ready for absorption. So this is absorbed by intestinal walls and goes directly into the lymphatic system. There are lymphatic vessels all around your intestines which absorbs this. And these lymphatic vessels decoalase to form a bigger duct which goes directly, not only lymphatics, but also the your, I'm sorry, not lymphatics. It is the veins. And these veins coalesce to form a bigger duct, which you call the portal duct, which goes directly into the liver. So all absorbed materials from the small intestine goes directly to the liver. So the liver is the one that is the first organ recipient of all digested, absorbed materials coming from the small intestine and goes directly there to the liver. Now, since we're talking about our glucose, which is the representative of your carbohydrate, there in the liver, because there is a surge of so much absorbed materials, especially your glucose and other monosaccharides. Principally, we have glucose. So the glucose concentration increases. All right. Now, this is not released into the general circulation. The liver now tries to remove as much glucose as it can, depending upon the enzyme that it has. And glucose is absorbed into the liver cells, and inside the liver cells, they are being trapped. They are being trapped by an enzyme known as glucokinase. And you know what the kinase is. Kinase is an enzyme that add a phosphate to a compound. So if glucose, the phosphate is added to carbon 6. So it becomes glucose 6 phosphate. So the glucose 6 phosphate in the hepatic cell is now trapped. Now what do you mean by trapped? It's being trapped there. It cannot go out anymore. Once a glucose is phosphorylated, it cannot go out through the cell membrane anymore. That is what we term as glucose trapping. And the glucokinase is very good at it. That's the enzyme for glucose trapping in the liver. Other cells has also a mechanism like that, but it is not using glucokinase. Glucokinase is only found in the liver. Other tissues, other cells has a similar enzyme, and you call it hexokinase. From the word hexo, meaning 6 carbon atom sugar. And you know your glucose is 6 carbon, your fructose is 6 carbon, your mannose is also 6 carbon, your galactose is also 6 carbon. Now, hexokinase, differentiated from glucokinase, is that hexokinase is not specific for one hexose, one type of hexose. So meaning to say the hexokinase can phosphorylate glucose, it can phosphorylate fructose, it can phosphorylate galactose, or even mannose. So it is not really specific, but glucokinase is specific for glucose. It cannot phosphorylate any other 6 carbon atom sugar. So that's why it has a name glucokinase, food glucose. And the other one is hexokinase. It is not specific. It is for 6 carbon atom monosaccharides. You get it? All right. Now, these two enzymes, glucokinase and hexokinase, has different Km. Still remember what is Km? Try to recall. What is Km? Okay. It is, Km is amount of substrate, no? That brings about half maximal velocity. Okay. Half maximal velocity. So it's the amount of substrate that produce a half maximal velocity. All right. So when I say that glucokinase has a high Km, it means it needs a high concentration of sugar before it can phosphorylate. Now, when I say hexokinase has a low Km, and that has a low Km, it only requires a little amount of substrate in order to bring about phosphorylation. So, the two differ now on the amount of substrate that it can work. Glucokinase needs a very high concentration of glucose, while hexokinase only uses a little amount. Now, what is the advantage of this? You know that your liver is the first recipient of absorbed materials from the intestine through the portal circulation. No? So which means it has a very high concentration of glucose. Not only glucose, but other nutrients that are absorbable. Very high. And so the glucokinase works efficiently until this amount of sugar now in the blood, in the liver, has lowered down that the glucokinase does not function anymore. Because this is small amount na lang. And what is that small amount? That small amount is similar to your normal blood glucose content. So, because the amount of glucose that goes into the blood after absorption goes to around 200 to 250. No? And your amount of sugar in the blood is how much only? From 80 to 120. Di ba? Medtex. Mga medtech, tingog diha, nurses, 80 to 120 only. So when the blood glucose or the glucose now in the liver is around 80 to 120 or even 120, your glucokinase stops. So not all of the glucose are trapped in the liver. So the remaining glucose goes to the other tissues, so that the other tissues will have glucose also. Otherwise, if your glucokinase has a low Km, all of the glucose absorbed from the small intestine will be in the liver, nothing to the other tissues. Can you see how intelligent our Creator is? Pag nagkamali yan, ang hexokinase nandyan sa liver, wala. Wala lang glucose sa ibang tissue. Diba? So, hindi nagkamali ang yung Creator. Okay? And those who do not believe in creation, no, they do not believe on a supernatural being, then we can say that evolution did not make a mistake. Because in evolution, still glucokinase is still in the liver. No? Diba? Okay. Now, so it is there. Once it is trapped in the liver, so it stays in the liver. Those that are not acted upon by glucokinase goes to other tissues for utilization of glucose. And the first priority of the cells is always to produce energy first before it can do other function. So they must have always energy. And we already know how generation of energy is. Diba? Now, in the liver and other tissues, glucose is first used as a fuel for generation of ATP. And the first pathway that we took up was glycolysis. And glycolysis started with glucose 6-phosphate. No? Already trapped inside the cell, whether it is hepatic or extrahepatic tissues. Diba? All right. Your glucose 6-phosphate is acted upon by several enzymes in your glycolytic pathway. Then it is split into two. So you have two triose phosphates. And each triose phosphate, as it journeys in the glycolytic pathway, is converted to pyruvate. Okay? Pyruvate. So that means because there are two triose phosphates, for every molecule of glucose, you will have two pyruvates. Okay. Now this pyruvate goes into the mitochondrion because this glycolytic pathway occurs in the cytoplasm, and then the product of glycolysis, pyruvate, goes into the mitochondrion. Why does it have to go to the mitochondrion? Because the enzyme that converts it into acetyl-CoA is found in the mitochondrion. So further utilization of your pyruvate is converted to acetyl-CoA in the inside your mitochondrion, which becomes the substrate of your citric acid cycle. Still remember your citric acid cycle? No? Okay. Now, that is the aerobic part. When it utilizes the mitochondrion, and when it goes into the mitochondrion, you know, it will be oxidized in the citric acid cycle, and then the reducing equivalents that will be formed, reducing equivalents like NADH and FADH2, is being shunted to a chain of enzymes inside the inner mitochondria, in the inner mitochondrial membrane, which you call your electron transport chain, or what you call respiratory chain. And you know that your NADPH, once it is oxidized, it produces ATP, no? And of course, water. Okay, if ADH2 also will produce ATP and water. And that water, of course, cannot be formed unless there is oxygen. And so that is an oxidative pathway. Utilization of oxygen. Diba? Now, if the tissues becomes anoxic, meaning low supply of oxygen, the tissue in the glycolytic pathway will now shift to what we call anaerobic glycolysis. The first glycolysis we mentioned is aerobic because it utilizes your electron transport chain, the mitochondrion and the electron transport chain. Now, what happens in your anaerobic? The pyruvate that is formed becomes lactic acid. Because in the process of, or in the pathway for your glycolysis, you have produced or you have reduced NAD. That reduction of NAD becomes NADH plus H. And once they are reduced, they cannot be utilized in the glycolytic pathway because the glycolytic pathway uses oxidized NAD. Now, if you have a hydrogen attached to it, it cannot be reused again. And so, that NADH is being transferred to pyruvate. The two hydrogens there that it receives is transferred to your pyruvate, and pyruvate becomes lactate. And then you oxidize the NADH, becomes NAD, and can be used again in the glycolytic pathway. But lactate is produced. And there is no other way for that lactate but to accumulate in the cells. Excuse me. Although lactic acid is a weak acid, when they become in high concentration, they can change the pH of the cell. If they change the pH of the cell, then the cell may not function. And that happens in cramps, no? Muscle cramps, because there's so much overloaded of lactic acid. And the cells, the muscle cells, will not contract, will not do its work anymore. There is no relaxation, but there is always contraction. Okay? So that's how you get cramps. No? Then you will ask, how come the tissues become anoxic or short of oxygen? When you are breathing. Correct, you're breathing. I'll give you an example. If you are, let's say, in your morning jog, you're jogging in the morning, and you think, because you've been jogging for a long time, you think, okay, I can extend my jogging time. Instead of just 30 minutes to 45 minutes, I may go to 1 hour, 2 hours, or 3 hours. Continuous. Okay, fine. The first hour perhaps, you feel tired, but still you're stubborn that you must reach the 2-hour limit or the 3-hour limit. Continue. No? Continue. You want to test yourself because probably you are thinking already that you are Superman and Superman can endure so much abuse. No? Okay. Now always remember this, that your source of oxygen is from the lungs. So you are breathing. You are breathing heavily, no, as you run. But the exchange of gases inside the lungs is still the same. It does not accelerate. Okay, the flow of blood goes into the lungs. Now, your 240 molecules of hemoglobin inside your red blood cell may not be fully oxygenated, and then that blood goes back to the tissues. It carries only a little amount of oxygen. So, what happens is there is inadequate supply of oxygen into your muscles. And the muscles demand so much of oxygen. But the exchange in your lungs is still the same. Can you see now why there is deficiency of oxygen? There is a great demand in the muscle, but the supply is low. So what happens? There will be less oxygen. Anoxic conditions comes in. And in anoxia, your glycolysis shifts to anaerobic glycolysis in order to supply ATP, because you need the ATP for the muscle contraction because you continue to run. And so to the point that the cells can no longer function because of a low pH, because of the accumulation of your lactic acid. You get it? So that's how you get your cramps. So the muscle says, I cannot tolerate it anymore. So I'll let you stop. And how will the muscle let you stop? Go into cramps. They go against you. And when you're rested, because you cannot continue because it's so painful, huh? And when you are rested, the supply of oxygen now is being, returning to normal. And so the pain and the cramps, of course, stops because the lactic acid has now returned back to pyruvate. You get it? Okay, so that's the connection, no, of what happens. And then from your glycolysis, when we have plenty of supply of glucose, we always store it, no? First as glycogen. Yeah, glycogen. And when you have plenty of glucose pag yun, no, it will be stored as fat. Okay, so we are now storing our glucose because we are in a what you call feed state. But this only happens of eating fat, no, and having cholesterol is when we indulge in overeating or overstuffing. Diba? You will learn later on when we are going into metabolism of lipids that what makes us fat is not fat or fatty material. It is carbohydrate. It is carbohydrate. Okay, so excess carbohydrate now is being stored. And we have glycogenesis. Glycogenesis. And in glycogenesis, our principal enzyme is your glycogen synthase. Glycogen synthase. And your glycogen synthase is stimulated when there is increase of glucose. When there is increase of glucose, the hormone that is secreted by the islets of Langerhans of the pancreas is insulin. And insulin activates your glycogen synthase. So excess glucose is stored as glycogen in a series of reactions. And we remember that the linkages that is formed there, the glycosidic linkage, is alpha 1,4, straight chain, and if you have two other brands, alpha 1,6 linkage. No? So you uh, you do arborization. I mentioned already what arborization means. Arbor comes from, which means a tree. No? So your glycogen looks like a tree with its branches. Okay? All right. Now, the opposite of this feed state is fasting. And what happens when you fast? Now, there are times when we really, there's a big fast, like from supper to your breakfast the next day. That's an overnight fast. We always do that because during sleep, when you are asleep, you cannot eat also. You know, that's impossible. You cannot do that. Oh well, perhaps when you are dreaming that you are in a party, you're eating, and maybe you are chewing your blanket. Okay, so the opposite now of feed state is fasting, and we do fast, and that fast that I mentioned is from supper to breakfast the next day. Okay. All right. The principal enzyme for the breakdown of glycogen during fasting is your phosphorylase enzyme, which is activated by the hormone glucagon and the hormone epinephrine. Okay, so those two are very important hormones. Although there are some other hormones that affects your phosphorylase, but the principal ones are your glucagon and epinephrine. Okay. Now, in the liver, you have your glucagon. However, uh, your glucagon has a way of stimulating other compounds in order to activate your phosphorylase. Your phosphorylase removes or breaks alpha 1,4 linkage. And the enzyme that breaks a 1,6 linkage is your debranching enzyme, which is an opposite in glycogenesis to what we call a branching enzyme. You still remember, no? Branching enzyme which creates a 1,6 linkage. And on the glycogenolysis, the alpha 1,6 linkage is broken down by, or it is being cleaved by your debranching enzymes. All right. So, breaking down your glucose, and the product is glucose 6-phosphate, and glucose 6-phosphate is acted upon by a glucose 6-phosphatase. Then you have free glucose. And this free glucose is release to the blood in order that the concentration of glucose in the blood increases. And this is liver function. What about muscle function? Yes, it can also do glycogenolysis, similar to the liver. But the problem is the product. The product of your muscle is not free glucose. The product is only glucose 6-phosphate. And if it is only glucose 6-phosphate, it cannot come out of the muscle cell. It has to be acted upon by a phosphatase in order to remove that phosphate so that that glucose can go out. But unfortunately, the muscle does not have glucose 6-phosphatase. And as a result, the breakdown of glycogen in the muscle only goes down to glucose 6-phosphate, which is utilized by the muscle itself. And it cannot add glucose into the blood. However, just like in the liver, the muscle has a debranching enzyme. And the debranching enzyme acts on alpha-1,6 linkage. And the debranching enzyme produces free glucose. So, it is not really that the muscle does not contribute glucose to the blood. It does, but in significant amount. Because how many branches are there? Only in 1,6 linkage. Very, very few. It is insignificant. No? It is also the same in the liver. The debranching enzyme in the liver produces free glucose. No? The muscle does it also. But the amount of glucose that it gives to the liver, out to the muscle, out to the blood is very, very small, insignificant. So the one that augments the glucose in the blood is the liver because of glucose 6-phosphatase. So whatever glucose 6-phosphate is formed in the liver, it is acted upon by that glucose 6-phosphatase, cuts it off, and you have free glucose, and glucose now can go out from the hepatic cells into the blood. Do you have that? No? So that's your glycolysis, glycogenolysis. Glycogenesis, glycogenolysis. So we have glycolysis. So what's the next thing? We will go into when the body is in a fasting state. If the glycogen stored in the liver is already depleted, what happens? The animal is not eating. So, what does it do? It produces glucose from non-carbohydrate sources. And that's the chapter that we are going now to take up this afternoon. Gluconeogenesis. Okay? So gluconeogenesis is active in two organs,